Hello and welcome to Wednesday's edition of Cracking the Cryptic, and today we've got a puzzle by the great Dutch master Ard van de Wetering. It's called Four Triangles, I guess because these sort of triangular shaped lines that we could view in the corners of the puzzle. 5 given digits today, what an absolute treat. And Ard, if you're not aware of Ard van de Wetering, I would argue that his Sudoku puzzles have been played more than any other person in the history of Sudoku. Certainly, many of our videos, which have had millions and millions of views, have had puzzles contain puzzles that Ard created. So, yeah, a seriously amazing constructor. And one of the things I really admire about Ard is that he never stays in one type of Sudoku too long. He might make a couple of arrows puzzles, he might make a couple of thermometer puzzles, but then he comes up with totally new rules. So this one is a completely original rule set, and basically the way it's going to work is that all these lines you can see are 4 cells long, and sort of those 2 digits will add up to those 2 digits. So the first 2 digits on a line add up to the last 2, and that's all the rules. So I've sort of explained the rules. If you want to kick off and have a go at the puzzle, then do that. But you'll miss out, I would argue, on some of the community-related things that I like to talk about at the start of these videos. So let me firstly thank all those of you who joined us last night. Mark and I had a go at the game Tametsi. If you're not familiar with Tametsi, look, there's a picture here. This is what Tametsi looks like. I don't think we got to play that puzzle, but we played lots of others. And it's sort of like hex cells, which is sort of like Mad Minesweeper. That would be a good way of describing it. Very, very good game. We're certainly going to return to it, probably at the same time next week. So look out for that. If you're subscribed, you'll get a notification once we can align our diaries. Oh, yes. Now, thank you to all those of you. And there have been, well, I would guess maybe 20, maybe 20 of our viewers have written to us today to say that I should have a go at a New York Times game called Strands. Well, I did, and I recorded myself having a go at it. I don't know where that video will go. It might go on Patreon. I'll try and persuade Mark, though, that we should release it on the main channel, in which case that would probably be tomorrow morning. But yes, thank you very much to all those of you who suggested it. I did enjoy it, and I do understand why you recommended it now. I won't spoil the puzzle by saying anything else. But yeah, I'd never played that game before. It was quite good. I might keep playing the New York Times Strands games. What else do I want to mention? Over on other things over on Patreon, we've released one of our old Patreon rewards as a free pack. We did that yesterday. It's called Duality. It's by the Sudoku Skunk Works, so a massive, massive mark of quality. And the reason we're doing that is that we're teasing the release, which is coming on the 1st of November, of Duality 2. Let me show you. This is the sort of promo for that. And Duality 2 is a Sudoku hunt featuring lots and lots of lines puzzles. But in Duality puzzles, the lines do double duty. These are seriously high quality puzzles, honestly, folks. So look out for that. And in the meantime, you've still got several days left to solve our monthly reward for this month. I'm trying to remember what month it is. It's October, isn't it? Yeah, Caroline's Halloween special. That's Halloween Adventure. Now that's definitely more approachable. Next month's puzzles are a little bit more difficult than this month's puzzles, but very, very cool rewards that you get if you manage to solve the Paint by Numbers Institute puzzles, because you get the pictures in the Japanese Sum Sudoku. So just to mention that as well. Now, other things I wanted to do was some birthdays. Birthdays and other announcements. I want to thank Becky, who wrote a very kind email to us. It means a lot when we get kind emails. Thank you, Becky, for that. And for E. Parama, who also wrote very kindly to us, and I think was on last night's stream. And also Andreas, your email touched me as well, and thank you for getting a t-shirt. Then birthdays, Alicia. Alicia, you've turned 25 today, and I know this because your partner Fergal wrote to us and told us that you're on holiday in Spain at the moment, which sounds lovely. and he is trying to find you chocolate cake. I don't know how easy that is, actually. Well, let us know if that was achieved. And Alicia, many happy returns. Next, Max. You've also turned 25 today. And I know this because your partner Rosie wrote to us. And I know you're doing a PhD at the moment. It's taking a lot of your time. I do hope you're still getting a bit of time to solve some Sudoku and perhaps watch some Sudoku videos. And I know Rosie was planning on a chocolate fudge cake, so I hope I haven't spoilt anything there. And I hope it would be awful. Imagine if I said you're getting chocolate fudge cake and there was no cake. Oh, I could have landed Rosie in it. I know she had good intentions, Max. So anyway, I hope you had a great birthday. And then we'll go over to Montenegro, where I'm going to hope I'm saying this correctly. Is it Tikon? Tikon has turned 11 today. And I know this because your dad, Ivan, wrote to us. It could be Ivan as well. I'm never sure on pronunciations. I'm so sorry if I'm getting this wrong. But I know that Ivan, I'm going to have to make a choice. Ivan moved with the family from Russia a couple of years ago to take a new job. And I am told, Tikon, that you learn English, Montenegrin, and Spanish, as well as being talented in maths. That is phenomenal. Absolutely phenomenal. Well, I hope you enjoy these videos, Tikon. I hope you have a brilliant birthday today. And I know that you're having cake. I understand it's not chocolate, but Ivan assures me it's not banana either. So we can live with that. Many happy returns. And thank you for watching the channel. Now, with all that said and done, I've sort of done the rules to Ard's puzzle already, but I will read them properly. Let's have a look at 4 triangles by the great man and see what we've got going on. So we've got normal Sudoku rules. So we've got to put the digits 1 to 9 once each in every row, every column, and every 3 by 3 box. And then in each line of 4 cells, the sum of the first 2 digits equals the sum of the last 2 digits. So it is what I said. So let's look at this line. Those 2 squares add up to those 2 squares. Those 2 squares add up to these 2 squares, etc. That is everything. Do have a go. The way to play is to click the link under the video as usual. That will take you to a page that looks very much like this one, where you can play the puzzle on whichever device takes your fancy. But now I get to play. Let's get cracking. So, never sure with Ard. Ard does like set theory from time to time. We might have. Well, no. I'm more tempted by maths actually than set theory. There's something peculiar. These lines aren't the same length quite. They are, but that line seems to extend more into this box than this line does, and this line does. Yeah, I mean, I think we can do some maths though, because the secret must be our friend here. What the mathematical property of each of these lines is that it sums to an even number, and we know that because the constituents of each line balance, don't they? So the first 2 cells add up to the same as the last 2 cells. So imagine that the blue there add up to x. Well, these will add up to x, so the line overall adds up to 2x, and 2x is even. Now, there is something that I know about a complete row or column of a Sudoku puzzle, and it's a secret I share with my very favourite people. If you're watching this video, you're definitely one of my favourite people. We have a t-shirt that says this now. Andreas bought one. The secret is that a complete row, column or box of a Sudoku, because it contains the digits 1 to 9 once each, must sum to 45. That is the triangular number for 9. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 is 45. Now, what that means is 45 is of its nature odd, but those squares we know must sum all together to an even number, because each line individually sums up to even. So that digit is odd. Now, I'm meant to use a colour, aren't I? I'm meant to use orange for odd numbers, because orange begins with O and odd begins with O. These are sometimes the logical leaps that we make on the channel. So this is definitely odd. In fact, the same is true there, so that's odd. That's odd. We're going to get a cross, aren't we, in the middle box, I think, because that's even, so that must be odd in row 4, that must be odd in row 6. So we've got all the odds and we've got the parity sorted out straight away in the middle box. Oh, well, no, better than that. Well, not necessarily better, but because I know these are even, these must be now a 2-8 pair, mustn't they? There are only 4 even digits in Sudoku, 2, 4, 6 and 8, so we can immediately dispose those around the central box. This is one of the things I really, really love about Ard's puzzles. They have a simplicity is not the right word, but it's, if I was to say an elegant simplicity, that gets closer to it. It's very clean logic, but it is very satisfying logic. I can actually see this digit now is not going to be able to be a 4, I think. Because if those 2 digits add up to 6, which they would, how would we make this domino add up to 6? It couldn't be 2, 4, and it couldn't be 1, 5. So I think that's our first digit in the puzzle. So this is 8 now, this line. So these squares add up to, well, okay, these add up to 8, but they're not 2, 6, and they're not 3, 5, so they're 1, 7. I don't know whether I have to continue the parity shading. Oh, why not? Why not? Let's do it. We'll parity shade everything for the time being. It might not be necessary, and see where we go next. Which is a very reasonable question, and I don't know the answer yet. Do we have to... Oh, yes, okay. I was going to say, do we have to continue to think about parity? And I think that's not perhaps a silly idea. We can look at those 2 digits there. Now, I do actually now know what the parity of these is, but before you think about it, you don't know what the parity of these is. But you do know, if you think about it, they have the same parity. And that's because, obviously, this little collection, that domino there, adds to the same as this domino, and these numbers are both odd. So if we were to make this odd, this would have to be odd, because we'd be going for even overall, and if this was even, this would have to be even, because we're going for odd totals in our dominoes. So these have the same parity. How could that parity be odd? If this parity is odd, we've got 6 odd digits in row 5, and there are not 6 odd digits in Sudoku. 1, 3, 5, 7 and 9 is 5 odd digits. So these are definitely even. They're from 4, 6 and 8. The 6 doesn't actually help with that. But the total on this line then is either 9, 11 or 13. The difference between these 2 digits is either 2 or 4. So the difference between these 2 digits is either 2 or 4. that's no use at all. Sorry. What else could we try? This has got to have 1 even. It's got to have 1 even digit in these digits. So there's also, oh yeah, okay, we've got to put 3 and 9 up here. Oh, but you could put them together. Yeah, I was wondering whether we could rule out them being a pair, because 3 and 9 would add up to 12, wouldn't they? But that domino could add up to 12 if it was 8 and then a 4. But oh, that's beautiful. That is beautiful. Right. Okay, I love that. This is just so elegant. Right, so what we do have to think about 3 and 9 in this collection of digits. So what we can see is that either 3 and 9 are paired up in this collection, in the sense that they're in one of the dominoes that has to sum to the other domino. That's one possibility. The other possibility is that the 3 and 9 are shared between this domino and this domino in some manner. Now, if the 3 and the 9 are split up, so they're not in a domino, what is the difference between 3 and 9? Well, it's 6, isn't it? So the difference between but between this digit and the other digit that we would have to have in here to achieve the balance would have to be 6. And that would mean that we'd need the only even digits that are 6 away from 2 or 8 are 2 and 8. But that we can't put 2 and 8 in this string because it would clash here. That's weird. That's so beautiful to me. I don't know if I'd love to know in the comments whether other people see that and just think, gosh, that's really, it's so well constructed and thought out. So now those two have to be a pair that add up to 12. So this has to be 4, that has to be 8. 4 is definitely even. These squares are now 6 and 8. So we can definitely limit this square. If this is 11, this is a 3. And if this is 13, oh, this is a 7 bobbins. Okay, that didn't work. No, okay, so we might have to think about other things then. What else could we think about? We could, oh, this is a 2. I might as well do the Sudoku if it's there. What about this row though? 3, 5 and 9 to place. Oh, I haven't looked at this. Oh, I'm so sorry, look. That hasn't only just appeared, has it? I just didn't look at it. Look, I've got 12 here. So this has to be 3, 9. It can't be 1, 7. And I get this digit as a 5 in the middle box. 5 very often in variant Sudoku ends up in the middle, so that's slightly surprising. 9 is now in one of those squares. I mean 3 is in one of these squares, so this digit is 1 or 7, I think. 3 and 9 are both odd, aren't they? So we can keep doing our shadings. Right, and now we have decisions to make. Do we do... I don't really know where to focus here. That's one of the great things about a totally new rule as well. You sort of, it takes away a lot of your experience, your intuition. 1, 5, 7 and 6 is over here. But definitely this has got 5 and 6 on it, hasn't it? That seems to be the case. So 5 and 6 add to 11, plus 2 is 13, to which we're adding either 1 or 7. So we've either got 14 or 20 as the total for the line, which means that the pairs either add up to half, so half 14 is 7, so this would be 2, 5 and 1, 6, or 10. Oh, hang on, I must have done something wrong there, because 10 doesn't work at all. 5, 6, 7. Why doesn't that work? It doesn't work, does it? So, sorry, yeah, what I'm saying here is if these are 5, 6, 7, have I got my Sudoku wrong or something? That just feels strange that doesn't work at all. I mean, mathematically it just doesn't seem to work. There doesn't seem to be a way of splitting the line into the correct portions. Because if the line adds up to, well, it would add up to 20. 5, 6, 7 is 18, plus 2 is 20. So this domino should add up to 10. And it can't be done. Right, so what instead we're going to have to do is do 1, 5, 6 here. We have to keep 7 off the line, basically. And then we're going to 14. So this has got to be 5. These have got to be a 1, 6 pair. Let's tidy up our pencil marks. 5 is definitely odd. 1 and 6 are one of each, so we can't do those. But we do now know these digits. They are 2, 4 and 7, apparently. That's good. That's good, because that's getting me this digit. Now, what do we need these? We need a difference of 2 in this one's favour. So that's got to be 8. That's got to be 6. these squares are now 1 and 9. Now, that must be helpful. Well, let's work out the maths of this line. We've got 2, 4, and 7. Sorry, it's not Maverick today. That's some sort of policeman, it sounds like. We've got 13 there. So if we add 1 to that, we get 14. And then we'd have to make 7s, wouldn't we? Which we can't do if that's a 1. I can't make those add up to 7. So 9 better work, or I've definitely made a mistake. So 13, 22, we need 11. 9, 2, 4, 7. That does work. So 9, 2, 4, 7, 1 in the middle of the grid. 2 is definitely even, so let's keep going with our parity. And we've done very well now, actually, haven't we? Because we have basically done... We've done the middle rows of the grid. But then, then we get the question, which line do we look at next? Do we want a big digit on the line? Or maybe that digit? If that's got a 9 on it, that's very difficult, isn't it? Oh yes, okay, that doesn't work. If this is 9, this is 15, isn't it? So these have to add up to 15. Now what they can't be is 7, 8, because I've got two 8s looking at them. So they'd have to be 6, 9. That's the only other way of making 15. But the 6 in that 15 would have to be here, and it can't be. So I think that's got to be 3. That's got to be 9. Now we've got 9 on the line, so these two have to be... Oh, that's gorgeous. This is just... It is such expert setting, because the moment you know you're going for 9, what is the nature of the number 9? It's odd. How do you add two numbers to make an odd number? One of them is even and one of them is odd. Now this square sees 2, 4, 6 and 8, so that cannot be an even number. That's odd. This is even by parity. So this is a very small number. It's 2 or 4. It can't be 6 or 8. So the difference here is either 6 or 4. Which means these are the same parity, doesn't it? So those are both odd. They can't both be even, or we would have too many even numbers in the column. So we're looking for a difference of... If it was 6, it would have to be 9, 3 or 1, 7, which would have to be 1, 7. But if it was 4, it then couldn't be 3, 7, but it could be 1, 5 or 5, 9. That might not be the way to do that. What about this digit then? These are adding up to 9, aren't they? So that's 7 or 5. Well, that doesn't really help us. Oh dear. Oh dear, dear, dear. Okay, so let's think again. Six is in one of those squares. You know I'm desperate when I'm resorting to Sudoku. It's really weird, actually. There's quite a lot of odd digits in column 5. Is that somehow relevant? We just can't really do Sudoku, can we? Because we know so little about the top 3 rows and the bottom 3 rows of the grid. So there must be something I'm missing, actually. There must be something I'm missing. What is it? Is it something to do with... Maybe it is this line. Is there more I can learn from it? I know the difference in the odd numbers is either 6, which would have to be 1, 7, or it's 4. If this is 4, I need a difference of 4 in the odd numbers. So again, then I couldn't put 7 on the line, but I would be putting either 1 and 5 or 5 and 9. Which I don't think is improving anything at all. The opposite of this has to be down here. This is bizarre. What am I missing here then? Can I do some Sudoku? No. I thought maybe I could do some Sudoku, but that doesn't seem to be a sensible way of approaching the world. Could I do... It might be that we have to sort of envisage what happens if this is 1, 7. It would put 1, 7 down there and then do some calculating. But surely there might be something a bit easier. I'm just not sure where to look, honestly. We could do... Is it this line interacting with this somehow? This would be... Oh, my door's moving. One of these digits is on this line. 9. If 9 is in here, then 9 has to partner up with 5, doesn't it? So what we'd be having is 13 here and 9 and 4 here. So perhaps that's rule outable. So we'd have 9, 5, 4. So 1, 2, 7 would go down here. 1, 2, and 7. So this would be... Oh, that's an interesting thought. Right, hang on, I've had a different idea. Ah, okay. Ah, okay. Yeah, I think it is. I think it's this column that we have to think about. Let me just mull this over for a moment. What we can't do is the mathematics of that correct? 42 has to be divided between 2 lines. So what we can't do, if we were to have, what I'm seeing is if this bottom line adds up to 24, that won't work because of this 6. Because if it adds up to 24 overall, then the parcels are going to be 12 each, aren't they? And this is going to have to be a 6, which won't work. And when I was doing the maths there, I was thinking I was going to end up with 24. But I'm not sure if I end up with 24. Let me just think about this again. Sorry. Bear with me for a moment. Yeah, because if the difference is 6, we have to go with a 1, 7 pair, don't we? And then I think I do end up with the wrong total. Yeah, so let's think about this again. So, if this is a 2, the difference in the even numbers is 6. So the only way this can work, because it can't be 3, 9 then, is with 1, 7. So this line, this top line, now adds up, I think, to 18. 18 and 3 is 21. That bottom line adds up to 24 and cannot be made. That's quite hard. There might very well be an easier step than that, but I mean, actually, it's hard, but it's quite beautiful, isn't it? It really is. Now we can do the order of this, because they have to, obviously each parcel has to add up to the right number. Now I know what these digits are, and this is we're going to be away, aren't we? Because now this line adds up to, I want to say 16. Yes, so we've got to do 8 parcels, so we get a 1, 7 here. Right, these two digits can't be the same number. Let's do our parity though first, because that's probably a sensible place to go. Oh, actually, I can get a 2 in one of those squares as well. Might be Sudoku of all things. But what I was going to say is these can't be the same number, because the implication of, let's say these were both 1. If these two add up to these two, these would be the same number, wouldn't they? So these are different versions of 1 and 7. So let's just quickly see if we can colour these to any sort of profit. What colour shall I use? Green? Or no, maybe grey. So that must be the grey one. That must be the purple one. So the difference between these is 6. So the difference between these needs to be 6. Which means, oh, and they can't be even, because the even numbers that have a difference of 6 are 2 and 8, and that can be neither 2 or 8, so these are both odd. So, I mean, even that sort of thing is just it's so beautiful, isn't it? Now, can we really use 1 and 7 here? No. No, you can't. This is gorgeous. It's just, this puzzle, this is one of my favourite puzzles, Ard, I have to say, because you've come up with something completely original, but the logic baked into this is really stunning. Now, yeah, look. So, if we do, the odd numbers that have a difference of 6 are 1 and 7 or 3 and 9. So these could be a 1-7 pair, and it could work, but only if these are different. But for these to be different, this would have to be the purple 1-7, wouldn't it? Because otherwise, if these are the same, this part of the line's either adding up to 2, being double 1, or 14, and the other side will take the opposite end of that equation, and it will not balance. So this is not 1-7, this must be 3-9. And if this is 3-9, that's most certainly not 6. And in fact, the order is known. That's 3, that's 9, so to have balance, we must go that way round. Therefore, that's 7, that's 1. We may not need our... Let's risk taking our flashing out. Now, has that... Oh, hang on, I could have got that digit. Didn't see it. This line has to achieve a balance. We have to achieve a balance in the force. In fact, I was watching... What's the 8th Star Wars film? Only recently. And I was struck by something Yoda said. We are what they grow beyond. It was something like that. That is the role of all good teachers or something. To be what your pupils grow beyond. And I thought, what a lovely way of saying something. Anyway, I digress. Let's go. Oh, 9 in one of these. 2, 4, 7, 8. Bother. I don't think it's Sudoku. Maybe Sudoku on this line. 1, 3, 6, 7. No. Oh, well, that is a 6 or a 7. Sees 1 and 3. No, I dispute whether it's Sudoku at this point. It's going to be something... Well, it's much more likely to be Sudoku mixed up with lines, isn't it? Because now I've got a reasonable total on this line. I've got 10 on it by Sudoku. And the other digit, do we have a feel for what that might be? Maybe. In fact, 9 is down here. Can this actually be a 9-5 pair? That would be 6-8. Bother. Maybe is the answer. Okay. Let me think. Sorry, this can't be a 1, can it? Because that would have a binary total, in the sense you can only make a total of 3 in one way, which is a 1-2 pair, and that couldn't be a 1-2 pair. If this is a 2-7 pair, oh, that's it. Look, no, let's not think about that. If this is a 1-7 pair, this would be a 6, and it can't be a 6 because 1 and 7 add up to 8, so this would be 2-6. That breaks. So as this is not a 1-7 pair, the 7 must in fact be here by that logic. So this has got to be a 1-8 pair now and add up to 9. That adds up to 9. 9 is odd. These squares now are 2, 3, and 6. So we can do the mathematics of this line. This line adds up to 18, I think. So we need 9 pairs, don't we? So 2 goes here, 3, 6 at the top. This is no longer a 2. 2 is even. These can't both be 1 for the same reason we looked at down there. So these have to be, well, they have to be different. That's perhaps all I can say. Which probably is not enough for us to do much with that. I mean, if this was 8 and that was 1, that is a big difference, isn't it? That's a difference of 7. So this would either have to be 1-8 or 2-9. I don't see a problem there particularly. And it's more likely, I think, that this is a 6-8 pair. And if it's a 6-8 pair, the difference between these digits just has to be even. In other words, they would have the same parity, which is probably easier. 5 goes up there, I've just noticed, by Sudoku. Okay, let's maybe try the bottom of the grid and see if we can find some luck down there. So 4, 8, and 9 at the bottom here. Plus 5, so this line's adding up to 26, so 13 pairs is what we need. Yeah, we do get a bit of, yeah, this is good. This is good. Okay, so we get 9 here, 4 here. We can do the shadings, and then these squares have to be 3, 5, 6. 3, 5, and 6 add up to 14. Plus 4 is 18. So we're looking for 9 pairs, aren't we? And this is a 3, 6 pair, which doesn't seem to be resolved, but 9 itself is odd. Oh, again, maybe these two digits having to be different could be interesting. Let's think about that. They can't be double 3. So, what can we determine from that? If that's 9 and that's 3, then we need a difference of 6, which couldn't be 2, 8, because that couldn't be 2 or 8. It could be, maybe it could be 3, 9 again though, although, what are we saying? 9, 3. No, 3, 9 wouldn't work. I think for the same reason that one wouldn't work. But there may be other versions that are possible. What about 1, 7? That might work. Yeah, okay, so perhaps that's not how to do it either. Or maybe it's better, if that's 3 and that's 6, then we need a difference of 3 on the line, but there should be loads of ways of doing that. Is this some sort of Sudoku mumbo jumbo that we're going to have to think about? 2, 3, 4, 5, 6. Oh, for goodness sake. Oh, that's an outrage. That's a naked single. I'm going to check it, but I think it's only got the option of being 8. Let's double check. This column needs 2, 4, 7, and 8. Yeah, that's a naked single. Okay. sees 2, 4 and 7 in the row. It doesn't actually, okay, does it do much for us though? Perhaps not. Let's pencil mark this column fully. That surprised me. Okay, so 1, 3, 1, 3, 5, 6. So this is a 1 or a 5 only. Whoops. That can't be 5. But what that might allow us to do is to think harder about this line again, mightn't it? So maybe that was what I was supposed to be doing before. So if this is 9 now, and that's 3, then how would that work? We need it to have a difference of 6 in this one's favour, which is clearly impossible. So if this is 9 and this is 6, we need a difference of 3 in this one's favour. And that would make this a 3 only, and it doesn't work. Gosh, that's quite complicated, but it doesn't work. I'm just going to show you that fully. I think that's right. So 9, 3, this has to be 6 different from this, and it just fails. 9, 6, this has to be 3 greater. This digit here is 3 greater than whatever we put here. So 3 and 1 are out straight away. But if that's 6, that has to be 3. So it doesn't quite work. So this is 3. This is 9. And this can't be 3 because these two digits will be the same. So this is 6. This is 3. Here we go. Here we go again. This is 7 now. Bit of Sudoku. That seems to be suggesting that that's a 6, which we'll certainly avail ourselves of. That is no longer 7, look. So now we get what looks to me like a 1-3 pair at the top of the grid. There is a 6 in one of these. Yeah, that's nice. If this was double 6, this would have to be a 9 because we need 12. So this is actually a 1. This is a 7, so that's a 4. And it isn't failing, which is something of a relief. The 1, actually, that's going to finish row 8, isn't it? Okay, so we need 1, 2, and 4 into these squares. Let's just pencil mark that up. This is a naked single. That's got to be a 1. So we get a 2-4 pair at the bottom of the grid. These squares are a 7-9 pair, which apparently is not resolved. These are 3-5-8. Oh, and I was going to say we might get a 3 in the corner, but we actually definitely won't. Right, how has this affected? The 6 has affected this. 6 and 1. The 4 has affected this. No, okay, no, okay, that was nearly good. That was nearly good, but it's not quite done enough. Probably we pencil mark these squares now, and then we might get home. Let's just check whether there's anything else obvious staring us in the face. Not seeing anything. Okay, so what is that digit? 2, 3, 5, or 8? Actually, that's interesting. It's only got the options of being 3 or 8. Oh, bother. I was going to say it can't be 8, can it? But it could if this went 8, 6, 8, 6. Which sort of feels like it shouldn't be allowed to do that. But I can't actually see from a Sudoku perspective why that fails. In fact, that is what it does. Because if this is a 3, we've got 9 here. And then we have to put a 1 or an 8 here. And it would clash here, or indeed in those two squares. That fails completely. So this is 8. And therefore that's 8 and 6, because we can't put 1 and 13 into those squares. So that's doing things. Yes, okay, that is doing things. Yes, it is doing things. Okay, good. So now, what do we need here? 7, 9 and something. Is it 4? So the only place for 4 in column 3 is here. this row needs 1, 3 and 9. Oh, my window's rattling now. So that should be a 9, according to that logic. That should be a 1, that should be a 3, that should be a 1. That's just Sudoku unwinding itself. This column, what do we need? Oh, the 5 must now go in the corner. And these squares are 2 and 3, so we can do that. This is no longer 2. This should be 7 or 9. That's not resolving itself by Sudoku, so we're going to need some help. Oh, the 9, it is resolving itself. That's good. Okay. This is a 4, apparently. That's going to do some work as well. And if we haven't made a ricket, we need to put 8 in, and the final digit is a 2 in the corner. And that is working from a Sudoku perspective. Now, admittedly, I've realised that I've somewhat abandoned my colouring at some stage, didn't I? So let's see if we can improve upon that. 9s, 3s, 5s, 7s, 1s. There. That is the final pattern. Yes, it's correct. Solve counter 2. So it's been tested and sent to me this morning, and very few people have looked at this. Well, hopefully a lot more people will look at it now, because that is absolutely spectacularly brilliant. I loved that. I mean, some of the early logic and the way that you could deduce the contents of the lines, basically through parity, but also thinking about balance. It was beautiful, wasn't it? I loved the idea of having to split, the idea that you couldn't split the 3 and the 9 apart here, because you'd need 2 even digits that were 6 apart, and that would break these 2 squares. Things like that. That is just Ard van der Wetering in a nutshell. Ard, take another bow. You are so clever and brilliant at constructing these puzzles. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.